Hey guys, welcome to Coronavirus episode number 2. This is Mr. Yakko here live at JCS, place that you are missing today. Here with some math class, geometry here. We're going to go over that quiz that you guys took yesterday, hopefully, and going to give you the opportunity to redo it and hopefully do better than the low score that you might have gotten the first time. Remember, all you got to do is watch this video and basically follow along and resubmit your answers there, and your score will be better. So if you don't do that, well, it's just an unwise move. And anyhow, hopefully this video helps you a lot, and let's do it. Let's go through this math stuff. Okay, first question. We have a parallelogram, and the diagonals are congruent and perpendicular. So then they give you 4 choices to pick which parallelogram has congruent diagonals, and they are also perpendicular. Well, remember, rectangles, okay, have congruent diagonals. Okay, so rectangles have congruent diagonals. As I try to draw a rectangle, let's try it again. Rectangles. So in a rectangle, you have the diagonals being congruent. Okay, so there you have it. And remember, rectangle has 4 right angles. Okay. Now, if you look at the angles here in that shape I just drew, does that look perpendicular? No. Okay, so not all rectangles have perpendicular diagonals. So you'll have to think about that a little bit more. That's a pretty easy question if you actually go and try to tackle it. I'll give you a hint. Not all trapezoids have congruent diagonals, just isosceles trapezoids. So anyhow, you better be able to get that one right. Look at your theorem sheet. It should be clear if you look at it and think a little bit. All right, let's go to the next one. So we have a rhombus. Okay, so this might help you on the previous question too. Rhombuses have 2 special properties that other parallelograms don't. Number 1, the angles are bisected, okay, by the diagonals. Okay, the angles are bisected. And number 2, the diagonals form perpendiculars. Okay, so you got those 2 properties. All right, now we can actually figure out Z, Y, W here. So Z, Y, W. Looking for this angle here. All right, so we know measure of angle XWZ, if I make an X, XWZ is equal to 77 degrees. Okay. Now remember the first thing I just said there, the angles are bisected. So we know that, say, YWZ, measured angle YWZ is half of that. And half of 77 is, I don't know, 33 and a half. Okay, no, that's 67. Half of 77 is, scratch that, 38 and a half. Okay, I want to check my arithmetic there. 38 and a half. Okay, so we have 38 and a half degree angle here. And then on the other side, it's also going to be 38 and a half because it adds up to 77. And guess what? A rhombus is a parallelogram. So since a rhombus is a parallelogram, what property about parallelograms do we know? Okay, well, opposite sides are equal. That's one. This problem has nothing to do with sides, so that doesn't really help us. What else do we know about parallelograms? All right, opposite angles, they are equal. So this angle here is the same as this angle there. Okay? So really, what I have in red here, this XYZ, measure of angle XYZ, as I write an O, which is crazy. All right, check that again. The measure of angle XYZ is equal to 77 degrees. All right. So think about what you're looking for, and that should be good enough to solve the problem, right? Sorry, I'm not used to the board thing, so I apologize for lack of eye contact. And I am trying to flip the slide right now, but I can only do it over there. In case you're wondering how I'm doing this, there's a laptop sitting on one of the desks in the front row. All right, so let's just do this next one here. All right, so we got this rhombus. All right, remember rhombuses have two properties that are special, the same two as before. And so that's going to be really helpful in this one because, boom, the diagonals form right angles, they're perpendicular, and so because of that, we have a right triangle here, and we're looking for, okay, what expression in terms of n can be used to represent AD. So you're looking for AD here, but guess what? AD, remember a rhombus is a parallelogram, so properties about parallelograms, opposite sides are congruent. So AD is actually the same thing as BC, all right? And so if we take this rhombus and we cut it up into triangles, we have right triangles. And how do we figure out sides on a right triangle? If we know two of them, the third one can be determined by Pythagorean theorem. Da da da. Okay, a squared plus b squared equals c squared. All right. So in this instance, okay, we could call this side A. Okay, so A is there, B is there. Remember, C is always the longest side, so it's opposite the 90-degree angle. C, in this case, is the one we're trying to find, which is BC. Okay, so BC is the same thing as AD. So if we find BC, we find AD. Okay, so we can say AD squared, okay, which is our C squared, is equal to A squared plus B squared. All right, now A is 4n minus 3. Okay, so I'm going to put that in parentheses, quantity 4n minus 3 squared, and then it's A squared plus B squared. All right, so that's A squared right there. Yeah, that's the A squared part. Let me move this down so I can actually have room to write this. Ooh, oh, try that again. Wants to dance on me. Okay, whoa, that really wants to dance on me. All right, so we have A squared. Okay, so we had C squared. Okay, we're actually writing the equation backwards. C squared equals A squared plus B squared. All right. Now, what's B squared? Well, B squared was the other side, 2n plus 5. Sorry, I got shifted there. Let me try fixing it. Wow. All right, there we go. C squared was equal to 2n plus 5. And no, C was equal to 2n plus 5. Sorry, I'll correct myself there. C was 2n plus 5. C squared is the quantity 2n plus 5 squared. All right, so now if we actually go and solve for AD, okay, this isn't solved for AD, it's AD squared. So if you want to solve for AD, you just take the square roots of both sides. Okay, so take the square root of this side and the square root of all of this. Okay, so it looks like ugliness, but it's not so bad. So there you have it. AD is equal to bah. Okay, I'm not going to take the time to write it, but hopefully you can figure it out from there.